All right, this is 8-2. You can add to this day 1. We're going to spend a couple days in 8-2. Now, here's what we're going to do. We're not going to take a break from solving, and in fact, the homework problems are going to have you continue to solve. I think we're going to get better at solving if we think about the sine and cosine graphs and just some of the really basic components of their graphs and how that's going to help us when it comes to solving. Okay? We're really not going to do a lot with graphing. I mean, really look at the graphing piece until about a couple weeks. Okay, we're really going to focus on solving, but again, I think it's good right here to just take a little glimpse at the graphs because it'll help. For the sine and cosine graphs, all right, we saw in chapter 7 that with the unit circle, with a few well, this is just with sine and cosine. Every angle that we could think of with the help of the unit circle has a sine and a cosine value. Okay, and by that I mean that we use coterminal angles, so we could look at like the cosine of 900 degrees or the sine of 7 pi. Okay, it wasn't just from 0 to 360 or 0 to 2 pi. We could evaluate essentially any angle we wanted. The range, however, is still restricted because sine and cosine values can't be bigger than 1, and they can't be less than -1. Okay? Now, to just get a really basic look at their two graphs, I'm going to start with sine. I just want to look at the quadrant points, which would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, really easy points to read off the unit circle. And in fact, it might be helpful if you have a copy of the unit circle available and that you're looking at that yourself. Remember, with the sine value, I'm looking at the y-coordinate on the unit circle. For a 0-degree angle, it's 1. Excuse me. For a 0-degree angle, it's 0. At pi over 2, sine is 1. At pi, sine is 0. At 3 pi over 2, it's -1, and at 2 pi, it's 0. Now, in this graph, if I were to say that this is 1, and that's -1, I'd have this point here. It would hit 1 at pi over 2, 0 at pi, -1 at 3 pi over 2, and 0 at 2 pi, and would look, okay, something like that. Okay, that's the basics of the cosine curve. Okay, its period, and this is a really important topic, is 2 pi. Because after 2 pi units, which would be right here, this graph would start to repeat. Okay, and that's kind of the big picture with the sine and cosine curves. They are called the periodic functions because they help model data that follows a repeating pattern. That's kind of the big picture of their applications. Let's do the same thing with cosine. We'll start at 0, then look at pi over 2. We'll look at pi. We'll look at 3 pi over 2, and we'll look at 2 pi, the exact same points. Now we're just looking at the x-coordinate. For a 0-degree angle, its cosine value is 1. At pi over 2, it's 0. At pi, it's -1. At 3 pi over 2, it's 0. And at 2 pi, it's 1. So now let's do the same thing graphically and just plot these points to get a look at what the cosine curve is like. We got that point. Pi over 2 is 0. At x equals pi, y is -1, 0, and 1. So it immediately starts to decrease, hits its minimum, and then comes back up. Cosine also has a period of 2 pi. Okay, that's because there's 2 pi radians in the unit circle. It's not a coincidence that those are the same. Really, the only difference between sine and cosine is where they start. Sine starts at 0, and if you look at the graph, you can kind of think about that as the middle. Cosine starts at the top. Very similar functions, which is why they go in the same category and they're taught together, because they're periodic functions. I want to talk for a bit about period and amplitude. All right. These affect the graph in some very specific ways that are relevant to us. Essentially, it stretches the graph both vertically and horizontally. The amplitude, okay, we already mentioned here that if we don't adjust the graph at all, its period in radians is 2 pi. Amplitude stretches the graph vertically. Okay, the period of the graph is really all about how it's stretched horizontally. Okay, that's related by this. The period length of a sine or a cosine graph is equal to 2 pi divided by b, where b is the coefficient in front of our x variable. Okay, the amplitude a is the coefficient in front of our trig function. Those are the only two that we're going to look at today, and we're not going to look at specific points or look or produce any really accurate graphs. We just want to talk about in general how these numbers affect the graph. So here we have 4 sine of 3x. Okay, I don't want to look at anything really specific on the graph. I do want to mention that its amplitude is 4. Okay, and what that means on the graph is instead of this graph going between 1 and -1, it's going to have a max up at 4 and a minimum down at -4. It's going to be stretched vertically. Here we see that b is 2. Okay, this number affects the period of the graph. It's no longer going to be 2 pi. In fact, because the period of any sine or cosine graph is 2 pi over b, it's going to be 2 pi over 3. Okay, it's going to be 2/3 pi. That is much shorter than 2 pi. Okay, whereas the original sine curve would have been something like this. It would have gone, let's see, up to 1, back to 0, down to -1 and 0. Okay, I know that's not real accurate, but it's just a sketch. This new graph is going to start at the same point, okay? However, we are going to see that is where its period would end at 2/3 pi. Okay, and the time it would typically have taken the graph to do one period, this graph will do 3. Okay, that's what the 3 is all about. It shrinks it down, and this graph starts to repeat faster. Again, we're not going to look at any specific table of values with those, but in general, that's what that value for b does. The graph starts to repeat faster, and it does more periods in 2 pi. Instead of 1 period in 2 pi, this graph is doing 3, and its new period length is 2/3 pi as opposed to 2 pi. Okay? Let's look at another one. -2 cosine of 2x. Okay, this is going to stretch the graph out to 2 to -2. Okay, but again, I want to pay really close attention to this value for b. 2 pi over b is the period, so for this graph, its period will not be 2 pi, it'll be pi. Okay, so it's going to end right there. Okay, the original cosine graph would have looked something. I'm going to put the original one in blue, actually. Starts at 1, bottoms out at pi, finishes at 2 pi. Okay, this graph is cosine of x. This 2 for the amplitude stretches it. The negative sign, which we haven't talked about until right now, means it starts at the bottom instead of the top. But again, this 2, that 2x, means its period length is pi as opposed to 2 pi. So it'll hit its max, come back down, and then it will repeat again. And once again, we see that it's completing periods of its graph faster, twice as fast. That's why b is 2, okay? When you get back to solving, and we have a number in there, it becomes really significant, because what happens is, we've seen so far when we're solving trig equations that we typically get 2 solutions. Well, if we have something going on for a value for b, we can get more than 2, and knowing this number as to how the period has been adjusted becomes really, really important to help figure that out, okay? Because I'm going to refer to period length when we're solving in the second day of 8.2, and I want you to have a good sense of what I'm talking about, because we're not really going to go any further with the graphs other than to know that this number out in front stretches it. This number in front of x changes the period from 2 pi to whatever we get from that equation. Okay? We'll call it quits there. That's the first day of 8.2. What we're going to do is take this stuff in the second day and apply it to solve some more complicated trig equations.